Welcome back to Basic Mathematics. In this video, we're going to be talking about writing equations. As always in mathematics, the big idea, the big goal for everything is problem solving. Looking at the rules of mathematics that we've developed and finding ways to use them to satisfy curiosities about the real world, about everyday life, about specific problems in specific disciplines, whatever the case may be. And in terms of equations, being able to take expressions spoken in the English language and turn them into mathematical symbols to work with is the big idea of all of that. As we've seen throughout this course, the problem with that is that English is a very flowery, poetic language. Mathematics is a very rigorous, regimented language, and trying to go between the two can be a challenge. So without further ado, let me get my head out of the way, and let's dive right into an example. Three less than a number. The phrase a number is very often the phrase used to indicate that the thing we're looking for is a variable. So when we see a number, we're going to write x. And if we want 3 less than that number, that means we want to start with that number and subtract 3. In terms of algebra, 3 less than a number means x minus 3. A little bit more complicated, 4 more than twice a number. Once again, this idea of a number, we're going to represent as x. In this particular case, we want twice a number, which means we want 2 times x, but that's still not the end of the story. We want 4 more than that. Once we figure out that we want twice a number, we then take that thing and add 4. So 4 more than twice a number in symbols would be 2x plus 4. Three times the sum of an unknown and 8. Different phrase this time, an unknown, different way of saying the thing I'm looking for is x. Building out from that idea of unknown, I notice here that I want to do 3 times something. But notice that it wants to be 3 times the sum. So it is important that I take 3 and I multiply it times stuff being added together. Because multiplication usually happens before addition in the order of operations, that means I'm going to need to have that addition in parentheses. All right, the sum of an unknown and 8, we already established that the unknown is x. Sum is the result of doing addition, and we've got an 8 here. So 3 times the quantity x plus 8. 3 times the sum of an unknown and 8. With that warm-up under our belts, let's take a look at an equation. 3 more than half of what number becomes 7? Notice immediately that this is a complete sentence. We have a verb here, the word becomes. We have punctuation. Whenever you have a complete sentence, that's your cue that what you're looking at is going to be written as an equation. And whatever verb happens to be there will be the equal sign. Anything that shows up to the before the verb in the sentence will be on the left hand of the equal sign. Anything that shows up after the verb in the sentence will be on the right-hand side of the equation. In this case, the right-hand side is fairly straightforward. We've just got 7 there. The left-hand side is a little bit more complicated. We've got our what number, we'll call that x, but we don't want just what number, we want half of that number. So that's 1/2 times x. And even that's not enough, because what we really want is 3 more than half of that number. So after we take half of the number, we need to add 3. Right, compacting that down a little bit to make it easier to solve. 1/2 x plus 3 is equal to 7. Now we have a very typical equation in one variable, linear equation in one variable. We want to get rid of the addition first, so we subtract 3 on both sides of the equation. 1/2 x plus 3 minus 3. 3 minus 3 is 0, and 0 plus anything is that thing, so we're left with 1/2 x. 7 minus 3 is 4 on the right-hand side. Then, to get x by itself, we need to get rid of that 1/2. You can get rid of 1/2 by multiplying by 2. 2 times 1/2 is 1, and 1 times anything is that thing, so we're left with x on the left-hand side. On the right-hand side, 4 times 2 is 8. Not a huge deal, but I do like finishing up a problem like this by actually writing out the answer in a sentence. Remember that x is something that I invented as part of writing out this problem. Right? The statement of the problem just said there is some number there. I filled in and called that number x so that I could do work with it. But x is something I know the meaning of. The person who asked doesn't necessarily know the meaning of x in this situation. This particular problem, it's straightforward because there's only one thing. But you will, as you continue on in math, look at problems that have 2 or 3 or 12 different unknowns. And paying attention to the difference there will tend to be confusing if you don't keep careful record of what your variable means. I lost a digit in there. Sorry about that. An industrial cleaning company charges $120 per hour plus a $75 startup fee. If a job cost $675, how many hours did it take to complete the job? When I approach a problem like this, the first thing I want to do, as has often been the case in this course, is to strip away all of the excess detail. I don't care that it's an industrial cleaning company. I don't care that the $75 is a startup fee. I care that there's a charge of $120 per hour, plus there's a charge of $75, and in total, that gives you $675. Now, to figure out from here, we have to think back to what we've talked about previously with unit rates. If we are taking $120 per hour, to figure out the total cost, we have to take that 120 times X, where X is the number of hours. And then the rest of this is pretty straightforward. Plus 75, verb is equal sign, and 675. I can subtract 75 from both sides of this equation. And then I can get X by itself by dividing both sides of the equation by 120. And once again, X is a thing that I constructed as the person solving the problem. It's not something that was there in the initial problem. So when we finish up and report our answer, it is important that we relay the job took 5 hours. That's something that makes sense to the person who is asking the question. X equals 5 might not be something that makes sense, especially in a situation where there's more than one unknown thing. I can't hope to come anywhere near showing you every type of application where you might be able to write out a situation, write out an equation to solve a problem like this. So I'm not going to try. But I hope that with just this one fairly straightforward problem, you're able to start to see the power of writing out equations and using equations to solve problems. So with that, I'm going to wrap up for this video and actually wrap up for this course. That's the end of what we are talking about. So take a look at the practice problems that go along with this video, and maybe I'll see you around.